So you just wrote some Java code, hit the run button in IntelliJ, and now there's error everywhere and you have no idea what to do. Well, it's time for some debugging. Luckily, IntelliJ's built-in debugger allows us to easily see what the code is doing, so we can pinpoint exactly what to fix and how to unblock ourselves. I'm Lucas, and here is exploring the IntelliJ debugger at CSE 373. Let's go take a look. We will be going through the following topics in this tutorial. Feel free to skip to any of them directly using the timestamps in the video timeline. Let's get started. To get started, we'll install our debugger visualization tools. For this tutorial, we'll use two of them. Number one is JGrasp, which you might have remembered from 143 or CSE 123. Next is a personal favorite of mine, Java Visualizer. They're each better and worse at each distinct thing, so with JGrasp generally being better at trees and linked lists, and Java Visualizer generally better at cross-functional scopes and variables. But we'll install both of them, and we'll take a look at how each of them fare later on. And you can use them side by side, simultaneously. They do not interfere with each other. To install plugins in IntelliJ, we crack it open, go to the plugin section, go to Marketplace, and search JGrasp. That looks like the correct screenshot, so we're going to install that. Now we're going to go to Java Visualizer, just searching Marketplace. And the author seems to check out, Eli, and we're going to install that. After it's installed, close IntelliJ, and reopen. Go back to the plugin section, and we'll see that they're both installed and enabled. So now we're ready to dive into one of our projects. With our visualization tools installed, we're ready to open our project. And here, I'm working on a linked int list problem. I have two files open. Here I have my solution method, and I built it using a main method and two helper methods that I call from within the main method. And here's my test suite, which calls the main method. And here, for simplicity, I've only left one single test that's been provided by the project. And so far, you want to be accustomed to running all of your tests by using the big green test play button up top. However, when we're trying to debug a particular thing, we want to narrow down our scope of investigation as much as possible. This will allow us to pinpoint more easily exactly what is going off with that particular method. So to do that, instead of running everything, we need to run each method individually. In this case, let's say that I want to investigate reverse 3 return correct list, and only that. So I can at least fix this first before I do reverse 4, reverse 5, or reverse 100. To run each method individually, navigate down to each method, and you'll notice to the left, beside the line number, there is a play button. Now in my case, you see that the play button is accompanied by an exclamation mark. That simply means that I have ran this before, and it did not pass. To run this method by itself, we hold down on the run test button, and we release on run. And there you go. As the left ping suggested, we have ran just a single test and nothing else. No other distractions, focusing just on reverse 3. But now you might think, well, is this any useful to us? We got our final result. How can we investigate this further? And that's where the debug mode comes in. You might have noticed a bug symbol at the top. And same thing with the top. For each method, we can also evoke the debug mode. So let's go ahead and choose that instead. And it actually gave us the exact same output. So what good does that do? Well, that's because debug mode supports something very powerful, breakpoints. As their name suggests, breakpoints are essentially ways that you can tell Java and IntelliJ to be like, hey, while you're running the code, I want you to stop exactly at this line. In our case, I wanted to stop basically at the start of reverse 3 because I want to see my linked int list get made. And so I will go ahead and place a breakpoint on line 21. You can do so by putting your mouse over 21 See how the 21 turns into a faded red dot? Clicking on it turns into a red dot and aligns the whole line in red. So now let's try to run debug again. And now we have stopped just before line 21. Java has stopped there and is waiting for our further inputs. You notice that in the debug menu, in addition to debugger console, which is defaultly included in IntelliJ, we now see the things that we just installed, JGrasp and Java Visualizer. Currently, because there's nothing inside the reverse sweep function, we can't see anything. But I'm going to hold our horses for a second here, because we're going to talk about these after we introduce the detailed inputs and commands that we can give to debugger. For now, let's talk more about breakpoints. So that's nice. One breakpoint. Can we add more? Certainly you can. I'm going to go ahead and stop our debug mode. Retract the debug window. You can add as many breakpoints as you want. And even breakpoints across different functions. Like if you know that, hey, I'm not feeling so confident about my list.front equals list.front.next, break right here. And if you break here, every time reverse sweep gets called, it will break there. And let's say, hey, this seems a bit tedious. How do I keep track of my breakpoints? Well, the most simplest way is to use the bookmark feature in IntelliJ. Crack on the bookmarks tab, and you'll see that in addition to bookmarks that you have manually placed, all breakpoints are automatically clustered under a big breakpoint bookmark. Clicking on any one of them will bring your cursor to them across any file. And if this doesn't cut it for you, there are also more advanced ways to control each breakpoint. For each breakpoint, you might have noticed, you can turn them on and off, as you can see here. But you can also enable and disable them. So let's say you don't want to just remove a breakpoint from your list because you want to revisit it later. Go ahead and right-click on it and check the enabled. That turns that breakpoint from a solid red circle into a dotted red circle, signaling that this breakpoint effectively will be ignored, but it still exists, so you can enable it later. And breakpoints can also have conditions attached to them. Let's say that for this breakpoint on line 33, I only want to execute it if the first element of list is, let's say, 5. To do that, right-click on it, enter condition. Let's go ahead and do list. And the autofill will work here because at this point in time, list is a valid variable. I can just do list.front.data is equal to 5. And that's it. This is now a conditional breakpoint that will only be executed when that condition is met. In the debug section, traverse to the 2 red circle button, view breakpoints. Clicking on it will review a comprehensive breakpoint editing section, which allow you to essentially enable and disable each breakpoint, as well as edit the conditionals. For example, I can simply suspend this one right here. By disabling the conditional, my data will be saved, or I can just delete it altogether. There are also other fancy stuff that you can do, such as print messages, but for now, we're going to focus on these, as they are more than enough for you to tread through any of your agonizing problems in this class. So let's say we have a lot of our breakpoints, and let's get started again. What do we do when we want to jump across our breakpoints? Let's bring our attention to this button, continue the program or resume program. Resume program allows the program to resume and stop at the next breakpoint. So if we look at it manually, the next breakpoint after this is going to execute this, enter our reverse sweep. It'll be this one on line 26 of our method. Let's see if it actually goes there. And there you go. It stops there. If I do it again, stops the next one, do it again, stop the next one, do it again, program finished because there are no more breakpoints between line 23 on this file and the end of the function. But the last convenient method that you can keep in mind is what happens if you're like, I'm just done with it. I don't want breakpoints. I'll just finish executing this. But we're in debug mode, so how do I do that? Well, instead of manually doing this and unchecking all the breakpoints, you can use a quick mode. Here, mute breakpoints. Click on that. They all turn into a gray dot for the duration of this debug session. Resume. Finished. And because the mute breakpoint button is on, any more times that you run the debug session, we'll also ignore all breakpoints. So, now you know how to tell IntelliJ and Java to stop at any point in the code. Now let's dive into what happens when you're stopped and you want to navigate around your code. And that's where the various step over, step into functions and features come in handy. With our knowledge on breakpoints, we are now ready to start dancing around the code. So let's go ahead and return to my initial objective. I want to see the new linked list on line 21 get created in real time. How do I do that? Well, let's start off by putting a breakpoint on line 21 and going to debug mode. So now IntelliJ has stopped right before line 21 and is waiting for my further input. Here are a couple of key actions that you should keep in mind of. The first action that we introduce is step over. Step over allows you to go over a single line, which is essentially executing the line that you're currently on. So if I step over line 21, it will execute line 21 and stop right before line 22, waiting for my next instruction. And why don't we go ahead and take a look at how JGrasp and Java Visualizer functions at this moment. If I go on JGrasp and I step over, we can see that a new list is created, the linked list. Similarly, for Java Visualizer, it also visualizes the nodes of the linked list. And we can step over again to go to the assert function. And already we noticed that, hey, I don't think my list actually got reversed. The 4 and 3 are missing. So you can probably know that it is most likely going to fail. We're going to go ahead and go to the next one. Step over again. And we are done. Java has finished the function and told us that the assert did not pass. So that's step over. But how do I manually go inside of my reverse function and check out what's going on? Because clearly, according to Java Visualizer, my linked list is definitely not working correctly. It's 3, 4, 5, but it ends up just being 5. Something is a bit off. And that's where the function step into becomes useful. Step into, which is located here, to the right of step over, will become accessible once you start a debug mode. I'm going to step over. And here, we can see that on line 22, we call the function reverse 3. So step into will allow us to go into that function call. Let's try it out. And now I'm inside my function call. JGrasp here still held up to my linked list. But what's so nice about Java Visualizer is that not only did we enter a new function, it also kept the frame of our previous parent function, allowing us to easily see how the references are handled. And remember, because linked lists are passed by reference, both of them point to the same object. Exactly how we would draw our environmental diagrams. And here, let's try out our newly learned skills. Step over, step over, step over. We're gonna have 3 now. 3, step over. And you can see here, both Java Visualizer, A and B, as well as JGrasp, will have local variables. But Java Visualizer allows you to easily see what is in the parent function call and what is in the current function call. So that's step over and step into. So what happens when we want to get out of a function? Well, If you are finished, you can simply keep clicking step over and it'll automatically bring you out to the parent. And notice how for Java Visualizer, the subcall disappears once the function is finished. And they're both visualizing our single linked list of just a single 5 node. But okay, so we can get out of a function by finishing our execution. But what if, let's say, I'm starting to debug again. I'm gonna go ahead and go into my reverse function. And I think I'm done. Like, I think my helper print function is actually working. I want to get out early. How do you do that? Well, that's where the third button here, which is step out, becomes handy. I'm going to click that. Step out will basically execute the rest of the function I'm currently in and bring me out. Essentially, a fast forward. And there is a fourth tool that combines all three of these functions. And that is, in the suite.more menu, run to cursor. Run to cursor essentially says that wherever my mouse cursor is, just bring me there, regardless of what the other parts are. So what that allows me to do is, let's say if I want to go to the int b equals 373 line, one way I can get there is by going to debug, step over, step into, over. Or what I can do is get into debug, stopped here, going here, put my cursor here, more, run the cursor. And I'll simply jump directly there. Now, alternatively, if you really want, you can also start the debug, put a breakpoint on B, and click resume program. And that'll still take you there. And yes, you can absolutely insert new breakpoints while you're in the same debug session. That works. But you might be wondering, so far, we've talked about step forward, step forward, step forward, step forward, step over, step out. Can we actually step back? Because I don't see a step back button here. And unfortunately, because the fact that computers cannot run backwards in this particular instance, we do not have a line-by-line step back. But what we can do is reset an entire frame so we can reprocess the function again. Let's say I start my new debugging session. I go into my reverse 3, go. Oh wait, but I actually want to see what happens on line 26. How do I go back? Well, you don't actually have to stop your thing and start it all over again. What you can do simply is recompute the entire reverse 3 function. Because if you step out, it will finish computing it and move on. There's something else. Reset frame. By clicking reset frame, it will take you out, but it will reverse you back to the start of line 22, allowing you to step in again and reprocess it again. In this case, we can see that we're surfacing more errors. So clearly, we got some pretty big issues to fix about our link list function. But that is reset frame. Now, something interesting to know is if you reset frame in a top level function, let's say in Java Visualizer here, there's nothing above this, and we still reset frame, well, that would actually just take you to some Java source code. And to do that, we actually just have to step out. And we're out back into our top function here. Lastly, I want to cover something about step into again. Notice my function on line 32. It actually calls 2 of my helper functions on the same line. So if I step into, which one of them is it actually going to step into? Let's take a look. And fortunately, IntelliJ is smart enough to figure that you probably have to choose. So in this case, I can either choose helper add function or helper print function. In this case, I'm going to choose helper add. So soon to going here, if I step over again, I'm back at line 32. And if I step in again, I'll go in the second one, the larger function, which is helper print. Finishing that, the function is now completed. Now, one thing that we do have to note here is if you decided that you wanted to step into the outer function first, you will notice that after finishing that, it doesn't let you step into the inner function. And this will be a good time to, again, reset your frame and go into your function again. This isn't as big of a deal for this particular method as it is relatively short, but for much longer methods and projects, reset frame will greatly help. But do keep in mind though, sometimes resetting might also cause additional problems. If something doesn't look right, the best way, of course, is the turn it off and on analogy, which in this case is to turn off the debugging process and start it again. So now, with all of our current debug knowledge, what can we do with it? Well, the most important thing to remember is that we are not simply constrained to the test suites that we're given. The local test suites, while nice, is not as comprehensive as the Grayscope ones, for example. And there might be specific behavior that you just want to test that the local test suite just doesn't cover. So what do you do about that then? Well, in my case, let's go ahead and define some specific customized tests for us. Here I've written a new function called make 377 palindrome, which takes in a list, any list, and makes a palindrome 37373. And I want to test this function. To make our own test, it's quite straightforward. So I've wrote a new function, my own test 37373, made a little linked list of just a single node with one in it, and I called the function on that. But I noticed that, hey, I don't have a play button next to it. How do I actually run it? Well, in JUnit, all we have to do to make JUnit recognize that what we just wrote is a function is by adding the @test attribute directly before it. As soon as I did that, you'll see that it recognized that as something I can run. So I can run that straight up. Now, yes, tests don't actually have to have an assert function at all. So if you just want to write it and then breakpoint into your function, that works. But for me, I'm going to add a list assertion similar to the one that we had here in reverse 3. Except instead of checking it to be 543, it will have to be 37373. And adding that and running that allow us to run our test. And if I, let's say, break a line here and remove the last 3, and run it again, you'll see that it fails because it cannot find the last 3. And this is also an excellent opportunity to see how JGrasp and Java Visualizer functions. So let's go ahead and do our same debugging process. Debug just that, enter breakpoint, debug itself, make it. And although right here, the link int list with a single element of 1 here is correctly shown by both JGrasp and Java Visualizer, one of the major advantages by Java Visualizer is its ability to showcase data structures across different functions. For example, as we run this, and we go ahead and step in, we can clearly see that inside our make 373 palindrome, because nodes are passed by reference, we don't have a separate data structure. We just have 2 arrows pointing to what was once the original linked list. JGrasp, on the other hand, does so in a much less explicit manner. In fact, JGrasp is only capable of visualizing variables in the current scope, where Java Visualizer visualizes it in all the scopes. But when we're inside a particular scope, they both work quite well. As we step over, they grow. And just like Visualizer, they grow. When we come out, both display the correct list. And yes,
let's return to the last example that we had. Java Visualizer, in this case, can not only showcase 1, 2, but 3 different function calls and how they correlate with each other. Where JGrasp just shows our current one. JGrasp shows A equals 143 and B equals 373, which is the 2 inside the helper add function. Visualizer, it showcases everything. So cross-stack analysis is something that Visualizer can do that JGrasp is just not too intuitive. So here is an overview of how to write your own customized tests, as well as the pros and cons of JGrasp and Java Visualizer. They're side by side, and you can click on them just like this. Zoom in, zoom out, up to you. I will recommend using them and see which one fits your likings. Perhaps some will be able to do better things than others. Perhaps JGrasp addresses trees better. Or perhaps Visualizer helped you discover that one pass-by reference error that you were just not expecting. But the most important thing is, here, you're equipped with an array of powerful tools to help you debug your code, to understand exactly what is going on inside the brain of Java on your computer as your program runs. And now, you have been taught how to use your own tests, so you can test anything that you ever wanted to. And the recommendation for that is if you're ever stuck on an annoying gray scope test, or just have something that you cannot figure out, write your own test case, however small, however big. And here you go, a beyond powerful set of tools that allow you to understand exactly what your code is doing.
And now it's time to put your debugging skills to the test. Stumped on the project, just open up the debugger and go absolutely wild. I'm Lucas, and this was walking through the IntelliJ Debugger for CSC 373. Happy coding, everyone!